In middle school, you learned about absolute value. Remember that the definition of absolute value is simply how far a number is away from zero. The absolute value of any number x is symbolically written like this. It is often helpful to use a number line when you're thinking about absolute value. Say that you want to find the absolute value of -4. This means that you want to know the distance -4 is away from 0. Using the number line below, you can see that the absolute value of -4 is 4. What other number on the number line has an absolute value of 4? In this number line example, you can see that there are two numbers with a distance of 4, namely 4 and -4. The same holds true for any absolute value, because there are always two numbers on the number line that are the same distance away from 0. Today in class, you worked on the task Bike Lovers. During the task, you continued to explore the idea of piecewise defined functions by looking at the different functions that describe Michelle and Rashid's bike rides. You have evaluated these piecewise defined functions at specific points and have also found their accompanying domains and ranges. Recall that the domain of a function is the set of all inputs or x values for which the function is defined. The range is the function's resulting set of outputs or y values. What do the domain and range of Michelle and Rashid's piecewise functions mean about their bike rides? How could you tell where the domain and range for each function were defined? Let's look at the graph of a piecewise function, g of x. Moving from left to right along the x-axis, you can see that the domain of this piecewise function is -5 less than or equal to x, is less than or equal to 7. Can you see how the domains of each individual subfunction come together to make the overall domain? What if the horizontal segment from 1 to 4 were removed from the graph? How would this change the domain? Now, moving up along the y-axis, you can see that the range of this graph is -5 less than or equal to y less than or equal to 11. Once again, consider how this range would change if the horizontal segment from 1 to 4 was removed. Did you notice that removing the horizontal segment between 1 and 4 changes the domain, but not the range? Why is this so? You studied transformations on quadratic equations in Math 2. In that course, you learned 4 ways to transform the parabola f of x is equal to x squared. The first is a vertical shift. Second, a horizontal shift. Third, vertical stretch. And fourth, reflection across the x-axis. In addition to representing the transformations on a graph, you can also represent them symbolically using the vertex form of a quadratic equation, which is f of x equals a times x minus h squared plus k. In this formula, k represents the vertical shift of k units. H represents the horizontal shift of h units, and a represents a vertical stretch by a factor of a. If a is negative, the parabola is reflected across the x-axis. Let's look at an example. Beginning with the parent function f of x equals x squared, shift the parabola 1.5 units to the right, 7 units up, and a vertical stretch of 4. Using the vertex form of a parabola, you can represent these transformations of the parent function as g of x is equal to 4 times x minus 1.5 squared plus 7. Here's a graph of the parent function in blue, f of x, and the transformed function g of x in red.